this is the start of chapter 3, dealing with length, area, and volume. And I know you'll notice that this is really similar to chapter 4, but there are some key differences. Mainly that we are going to start with just systems of measurements. We're going to review working with perimeter. For those of us that need a refresher, perimeter is the sum of all the lengths of all the sides in a polygon. Sometimes we have special formulas. For instance, a square. Perimeter of a square is equal to 4 times the side length. We also have the perimeter of a rectangle. And I have a habit of drawing the little shape right there. You don't have to, which is 2 times the length plus W, or 2L plus 2W, depending on which way works better. When the units of measurement are the same, you can ignore them during calculations, but you have to have the units in at the end. Because of the math that we are doing, if we have the wrong units, you will lose marks. To make sure that you don't miss any sides, start at one vertex and work your way around the figure. So for instance, what is the perimeter of this figure? Well, this figure has 7 sides. So this is a heptagon, which is a fun word. So simply all you're going to do is you have to add all of these sides together. So you'll have this side, so perimeter is equal to 4.2 plus 4.4 plus 2.6 plus 2.0 plus 2.1 plus 2.2 plus 2.8. And notice how I left off centimeters because they're all in centimeters. This is 20.3 centimeters. So you have to have that in at the end here. It doesn't matter that you don't have it in this bit, but as long as you include it back in at the end, and you have the right amount of significant figures, in which this case is 1, you'll be good to go. Calculate the perimeter of the following diagram. So this one is perimeter is equal to 2L plus W, or you can just add them. So 218 plus 0.3 plus 8.5 is equal to 2 multiplied by 18.3 plus 8.5, which gives us 2 times 26.8, which gives us 53.6 centimeters. From our trig unit, you should remember that this little guy right here means a right angle. This shape we have is 1, 2, 3, 4, 5 sides. It's a pentagon. So then this one, it doesn't have a special formula, so we just have to add everything all together. So perimeter is equal to 9.6 plus 12.3 plus 6.2 plus 5.1 plus 10.4, which leaves us at 43.6 centimeters. And again, centimeters. We have a 1, 2, 3, 4, 5. So again, this is a pentagon. And we're just going to add this all together. And then just remember that this side and this side are equal. So then we add this all together, which leaves us at 7.6 meters. Dharma is edging a tablecloth with lace. The tablecloth is 210 centimeters by 180. How much lace does she need? This one we can use a formula, or we can just add them. I'm going to show you that they do the same thing. So this leaves us equal at 780 centimeters, or you can do perimeter is equal to 2L plus W, 210 plus 180 is equal to 290 to give us 780 centimeters. Okay. Gary installs a wire fence around the rectangular pasture. The pasture measures 15 by 25 meters. And he uses 3 rows of barbed wire. How much wire will he use? So perimeter is equal to 2L plus W. 15 plus 25 is 40 to give us 80 meters. And this is for 1 row. So we have to multiply this by 3 to give us 240 meters for all 3 rows. Okay, next one. Chantel is building a fence around her swimming pool. The pool is 25 feet long and 12 feet wide. And she wants a 6-foot rectangular walkway around the entire pool. How much fencing will she need? So this means that we need to recalculate a little bit because we have this extra little rectangle on the outside. So I'm going to color this blue. So then this side length here comes in from here. So this is 6 plus 6 plus 12 to give us 24. And then this side is, oh, I think I did that backwards. I did. So this side is 6 plus 6 plus 12, which gives us 24. And this side is 25 plus 6 plus 6, which gives us 37. So then it just becomes perimeter is equal to 2, 24 plus 37, 61. Multiply that by 2, which gives us 122 feet. This is in feet. All right, on to our next example. The sides of the flower garden are shown below are 4 meters long. Each end has a circle that is a diameter of 2 meters. What is the perimeter of the flower garden? Okay, so we have our new formula here, the circumference, which is the measure of the area of the perimeter of the circle. So when we put these two semicircles together, it's actually going to create a full circle. So we're going to be left with a circle plus 2 sides of a rectangle because we're not going to calculate the little dots in here. So our circle formula is C is equal to pi d, which is pi multiplied by 2 to give us about 6.28 plus 4 and 4. And that's because these sides are just 4, which all together gives us perimeter, which is equal to 14.28 meters. What is the circumference of a circular fountain if its radius is 5.3? So our circumference formula in this case is 2 pi r. So then 2 pi multiplied by 5.3 is equal to 33.3 meters. Johnny wants to put Christmas lights along the edge and peak of his roof. How many meters of lights will he need? Okay, so I see 28 here, here, and here. So I'm going to, this is kind of like a layman's formula. So perimeter is equal to 28 times 3 plus 1, 2, 3, 4, 5. So 28 times 3 is 84 plus 20 is 104 meters of lights. You could definitely do 2 rectangular formulas and add them together, but you would have to make sure that you didn't calculate this overlap twice. So that's kind of why I broke it down like that. Hershey uses colored wire to make a model of the Olympic symbol, which is 5 circles that kind of interlock like this. If each circle has a radius of 35 centimeters, how much wire does he need for the ring? So C is equal to 2 pi r times 5 rings. So 2 pi 35 times 5 is equal to, and that gives us 1,099.5 centimeters. All right, now here's our new skill, working with systems of measurement. So this is, I'm sure you saw in our questions that we were dealing with a couple different systems of measurement. We were dealing with feet and centimeters. The System International is the one that we use in Canada, but we use a lot of the imperial system because of how close we are to the United States. Some are more used for like trade, so like feet and inches I know is more used at like home hardware, for instance. We also use feet and inches to describe our height in person, but we also use centimeters for our driver's license. And we also have like our ruler differences. Our rulers are usually divided into tenths, so like centimeters, meters, decimeters, and millimeters. But the ones down in the States are divided into halves, quarters, eighths, and sixteenths. These are the common imperial units of length: inches, feet, yards, miles, and those are the ones that you use to convert back and forth. This is our ruler, so this is the SI ruler, and this is the imperial. If you look on a measuring tape, you'll probably see both of these at the same time. For instance, you can even see on ours that we also have an inch. This is half an inch right here. And it kind of builds from there. Like in between 1 whole inch, there should be 16 dividers, and it kind of simplifies in from there. So Wilhelma, a seamstress, is sewing bridesmaid dresses. She orders the fabric from the United States, where the fabric is measured in yards. Each dress requires 3 3/4 yards of silk, 1 1/2 yards of lace, and 7 1/4 yards of trim. And I need to make 5 dresses. So the first thing that we're going to do is we have to convert all of these to improper fractions. So we have to multiply here, add here. So 12 plus 3 is 15 fourths, 3 halves. This is 28 plus 1, so 29/4. Then we have to multiply by 5. So this is going to be, it's going to be 75 fourths, 15 halves, and 145 fourths. Now, if we tried to order that, they wouldn't really understand what we were asking, so we need to convert back to a mixed fraction. So this one would be 18 3/4, 15 halves, which is 7 1/2, 145/4, which converts to 36 1/4. And these are all in yards. Okay, let's do some practice. Bernard is buying some lumber to finish a project. He needs 3 pieces of 2x4 that are each 4.5 feet long, 10 pieces of 2x2 that are each 5 1/4 long. How much of each does he need in total? Okay, so this is pretty similar to the last one. So we're going to have 4.5 feet times 3 pieces and 5 1/4 times 10. So let's convert this. This is 9/2 times 3. Then this converts to 21/4 times 10. Multiply that out, that gives us 27/2, and this is 210 over 4, and let's convert that. So this one converts to 13 and 1/2, and this one converts to 52 and 1/2 pieces of lumber. So this is how much I need in total for each. Benji is replacing some plumbing pipes. He needs 3 pieces of copper pipe. One piece is 2 feet long, one is 5 feet 7 inches long, and one is 4 feet long. How much copper pipe does he need if he loses 1 inch when he cuts the pipe and he can only buy in even numbers of feet? So this question seems a little bit more complicated than it is. So if I have 2 feet, we can think about this in terms of inches if we'd like. There are 12 inches in each foot, so this would convert to 24 inches. Whoops. And then we would lose an inch. Or the other way that we can think about it is that 5 feet 7 inches, this is how they write it, means that there are still 5 inches to spare. So if I bought 6 feet of pipe for this one, 2 feet of pipe for this, and 4 feet for the other one, I still have lots of extra space here. So really, this is just adding them together. So this, I only need 12 feet of pipe because I'm just adding these together knowing that I have 5 inches to spare. If each board and a fence is 6 inches wide, how many of them will Jose need to fence a playground that is 60 feet by 125 feet long? Okay, so my first instinct for this question is that 6 inches is approximately half a foot, which is not something that they love for us to do. So we need a playground that is 60 feet by 125 feet long. So for each 2 boards, I have a foot. Basically, what I'm thinking is that if we double this, I would know exactly how many boards that I would need. So if I have 60 feet, and each board is half a foot, in order to get this, I would need 120 boards. So I'm kind of setting this up like a proportion. So like 0.5 gives us 1 board. Does that kind of make sense? And then I'm thinking kind of the same thing for the other one because it doesn't change based on the length. So then if I needed 125 feet, it would double to 200, oh man, 250 boards. And that gives us one side, so then I would need to double this again for 240 plus 500 to give us 700 boards total. 740 boards. And again, I'm making sure to write my units because that's what I'm trying to find. Here's our last example before we go through the build your skills stuff. So Fatima is trying to calculate how much baseboard she'll need for the room. What is the minimum amount of baseboard that she'll need? So we need to find the perimeter of the room first. So perimeter is going to equal 9 feet plus 27 plus 5 foot 2 inches plus 27 inches plus 6 plus 9.2, not 9.29 to that, plus 15, 8 plus 9.2, not 0.2, I'm saying that wrong. I'm trying to say 9 feet 2 inches. Plus 24 inches, plus 24 inches, plus 9 inches. Okay, so if I add feet to feet, and that's all the ones that have just the single quote, and the inches to inches, so it would look like this, like inches, 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 inches. And feet to feet, we would get 44 feet, 140 inches. Now, this 140 inches can be converted by changing it to feet. So we get 11 feet, 8 inches. Add this together, we get 55 feet, 8 inches of baseboard. Okay. The other way that you could do this is you could convert it all to inches first and then to feet, but that's a little bit of extra steps. All right, a pet shop stores 5 pet cages that are 2 feet 8 inches wide, 3 cages that are 4 feet 6 inches wide, and 2 cages that are 1 8 inches wide. Can these cages fit side by side along a wall that is 30 feet long? So in this case, I think it would be better to change everything to inches and then to feet, just so we're multiplying properly. So then 2 times 12 plus 8 gives us 32 inches. 3, which is 4 feet times 12 plus 6, 54 inches, and 12 plus 8 to give us 20 inches. So then 5 times 32 gives us 160 inches. 54 times 3 gives us 162 inches, and this gives us 40. Now 30 times 12 gives us 360 inches. So 160 plus 162 plus 40 gives us 362 inches. The cages will not fit. By a little measly 2 inches. A circular garden is 6'4" in diameter. To plant geraniums every foot along the circumference, how many geraniums are needed? So, approximately every foot, it should just be 6, right? Like if we draw this out. Well, no, I did a common mistake. So this is the diameter. I jumped ahead too fast. So we need C is equal to pi d. So pi times the diameter of 6'4". So that is, I'm going to change that into inches again. Times it by 3.14, which is 238.64. And then every foot, I need to convert that back into feet. So I'm going to divide this by 12, which gives me about 19.88. So I would need 20 geraniums. Now, because this is feet, this is inches. This converts it to feet. The height of a basement ceiling is 7'2". A 6-inch deep heating pipe runs across the middle. To enclose it, there must be a 1-inch space between the pipe and the drywall. Will Craig, who is 6 feet 6 inches tall, be able to walk under the finished pipe? Okay, so here's what we're going to do. We have this 6-inch deep heating pipe. We assume that it's a cylinder. This is 6 inches, and there must be a 1-inch space here and here, I believe, between the pipe and the drywall. And this is already 6 inches. And if the wall is 7'2", and I'm taking away 8 inches, essentially, this should leave us with, go down 2 inches, that gives us 7 feet, and then another 6. So then if we subtract this is 8 inches, this leaves us at 7, 0, which is really the same thing as saying 6 feet, 12 inches. And we've already taken away 2, so we still need to take away another 6. That would leave us at 6 foot 6 inches. So he should be able to, assuming that we should have 1 inch on either side, which is my assumption for this question. And it could be wrong, but I think that's how it is. All right, that should be it. Thank you for sticking around. You can always jump through the problems a little bit faster if you don't want to work with them. And you should be ready for the assignment.